Okay, sorry about that one. So the problem in the power system, several problems in the power system are considered as a lightning switching of the real switching in the case of high voltage substations and the faults. Okay, what are the requirement for the protection system? First, you have to understand what's the meaning of one line diagram in the power system, then impedance and connection of the power system equipment, power frequency, voltage level, blah, blah, blah. Then you should find out the meaning of existing schemes, operating procedure, importance of protection, and maximum allowance time to clear the fault. The same as fever, which usually we call it, shouldn't be over 40 or 42 Celsius degree for human. The power system cannot withstand for a long, long time against the fault. So there is a set of time for each devices. This one is given by the manufacturer. For some devices, very important one, not more than 1 second. Okay, so the fault current cannot withstand for more than 1 second. Then maximum load, then CT and VT. Sometimes I have a PT, which is a potential transformer. We call it VT, voltage transformer, the same things, or CVT, capacitive voltage transformer. So these three are the same, which are totally different with the power transformer. Okay, so these are not the same. PT is exactly the same as these two. Then the other things. Okay. Here you can see a single line diagram. This is the short circuit level by a substation. Then the transformer type of connection, impedance of the transformer, the voltage level, and the transformer capacity. Then transmission, this is transmission line, impedance of the transmission line in different voltages, load. Okay, later we will understand this one. But we have two standard. One is called ANSI, the other one is called IEC, which represent the relay in the symbols and the forms. You can see here is one of the, what type of protection is this one? I didn't mention, but you can see different numbers here: 45, 49, 18, blah blah blah. Okay, what's the meaning of this one? Oh, okay. If we went to the ANSI codes, we can find out what's the meaning of this one. I think in the future slide I will go through that one. Okay. Right now, the effect of the fault and in the power system, you can see the bird and animals are one of the major problem for the power system. When the birds, this PT bird, you can see it's double phase, means electrocuted by double phase, and of course you can easily pass away. I think not more than seconds. The next one is a lightning. You can see this is a figure of the lightning and what happened to the power system. All the phases affected. As you can see, the spark on the other phases also appear on the power system. So what's the meaning of this one? This one for the relay means the transmission line is connected to the ground. It's really a strange. Yeah, I can understand, but the meaning is there for the relay to protect the power system. Okay, let me see the next figure. The trees, as I mentioned, the trees also, because the trees, inside the tree we have water, so the water is conductive, and we have mineral water also inside that trees. So if any wire or any branches of the tree touch the wire, that PT branch is electrocuted, and the energy and the electricity is sent to ground, and the system consider that one as a fault. Okay, switching. Have you seen such a videos? The ghost coming out when they open the switch with a really weird sound, really strange sound. Yes, this is the meaning of switching the power system. So if we open a switch under load, this is the result. Some switches, not all switches, but this is really. And the outcome of any false and bad switching is this one. This is a three-phase transformer burnt and whole power system is destroyed. This is another type, bushing after operation, maybe bushing of the transformer or bushing of the any protective devices. You can see all burns. This is another view of the transformer, three-phase transformer. You can see the holes and the problems. It means that the transformer failed. We have circuit breaker. You can see the figure of circuit breaker, different area. This is, I don't know, maybe in the Europe. This is somehow uh, in the Middle East or here, Middle East because it's very hot here because we have lots of raining. In the Europe, I don't know how they keep it inside these boxes, but whatever in the Middle East and here I saw such a these figures, which they put it on top of the earth. So circuit breaker are the switches can operate during fault, under load, and isolate the system from any problems. The next one, current transformer. Current transformer are the same as signals we have for our body. They controlling this current transformer controlling the current of the system. So if it is increased from certain value, the CT only measure that one, send it for the next stage, which is relay. So the relay can see the current increase and send the signal for circuit breaker. So the procedure is something look like that one. The current increase, step one, the current increase. Then what happened? CT, which is the measurement system, send it to relay. Then the relay send the signal and operation order for the circuit breaker. So circuit breaker will open the circuit. Potential transformer or VT or CVT, as I mentioned, it is used in the case to measure the voltage because we cannot measuring the high voltage in the same way as the normal condition. Okay, if we are going to convert, assume at 230 kilovolt to 110, okay, volt, which is the voltage for measuring, okay, we should order to the well-known companies such as Siemens, ABB, and the others, General Electric, to produce a big transformer, which is not feasible. We need them only for measuring. Very transformer are not used here in the case of the protection. So they usually using a voltage divider, one CT, one capacitor, the other capacitor, and then ground. Okay, this is connected to the line. This is 230 kilovolt line. Okay, this is C1, this is C2. From middle point of this one, we have a voltage dividing which the this is CVT. Okay, this is called CVT, and the measuring happen at this point. So this is the point we usually measure the voltage. So C1 and C2 reduce the voltage, then using a normal transformer, very small one, to convert the high voltage. This voltage is very small compared with 230, okay, but still is a high one. They're using other transformer to tune it on something they need and measure the voltage, send it in the same way for the first for the relay. Then if there is any problem in power system, the relay asks the circuit breaker to open. How the CT and PT are connected? Very important. Be careful. The CT will be connected in what? The CT will be connected in this way, okay? And the PT will be connected in this way. What type of way is that one? One should connected in series, one should connected in parallel. Okay? For the CT, the connection must be series. Okay? For the PT, a connection should be parallel. Okay, so don't forget that one. CT always connected in series, PT always connected in parallel. The major power system components, of course, is a generator. Then we have motors, which can be asynchronous or synchronous, induction or asynchronous. We have the loads, which is CT, the substations, and transmission lines. The other part of power system also can be considered, but these are the most important. Why? Because these two type of motors, these two and this one, can be considered during the fault. Means during the fault, this one and this one for a while, not for whole fault duration, can convert to generator. What's the meaning of that? It's the same. You're driving your car, okay? Just driving your car. Suddenly you change the gear to N. Is it going to be a stop? No. For few seconds, your car will continue until the fraction stop your car, correct? Or you using it as a brake or stop the car. So the meaning of that is exactly the same. When any fault happen in the power system, the synchronous motor or induction motor still start to rotate based on their inertia, and that one can generate voltage in the power system for a short while, guys. So you should memorize this one. Induction motor will be a generator only for 2 cycle after fault. Only for 2 cycle means since the fault happened until 2 cycles. So 1 cycle is 20 millisecond. So 2 cycle is another 20 millisecond. Then become a motor. Done. Finished. Synchronous motor can be converted to generator for 25 cycle after fault. So from here until 25 cycle, 25 times 20 millisecond. And the current direction will be reserved after fault for both motors. The magnitude of the fault current is determined by the fault type, impedance, location, inception, and blah blah blah. Okay. Uh, in chapter 3, we will discuss what's the meaning of this is will be explained more and more in chapter 3. Okay. But in chapter 3, we will explain what's the meaning of the time, different time scale and different value for X. What is X? Can you remember? Z, which is impedance, is equal to resistance plus JX, which is impedance, resistance and inductance. So this is somehow considered as a power system protected device. As I mentioned before, there is a table to explain that one. This is ANSI, this is IEC. You can go through and review the names and the number and the shape, I means the signs for the relay. Okay, I will continue by the next round. Thank you.